This video is about how to work with the distances and displacements and velocities all while dealing with vectors as well. Okay, so let's just say that the plane that we mentioned in the previous video was going 400 miles per hour this way, and it was going 50 miles per hour north, and we figured out that it had a resultant velocity of 403 miles per hour. Now, if I want to know how far it travels east, I just want to know how far it's traveling east. That is a direction that is movement in the x direction. It's moving in the same direction as the 400 miles per hour. So what that means is that if I'm trying to figure out the distance it traveled east in, say, 20 seconds, all right, let's just make that, to make it easier, let's just make that 2 hours. So I want to know the distance it travels east in 2 hours, right? I don't have to worry about this 50 miles per hour right now because it's traveling, the only velocity that's making it travel east is the 400 miles per hour. The 50 miles per hour is pushing it north. So it doesn't come into play when you're talking about the distance traveled in a specific direction along the x or the y axis. So if you're trying to find a distance or a displacement in the x or a distance or displacement in the y, you cannot deal with the velocities in the opposite direction. So a distance in the x has to go with a velocity in the x. A distance in the y has to go with a velocity in the y. Notice that neither of these can go to the resultant velocity. That's not the same thing. You can't do that. Alright? So it's got to either go to a velocity in the x or a velocity in the y. In this case, for our 2-hour demonstration, the distance east would be the distance in the x, and the 400 miles per hour would be the velocity in the x. So 400 times 2 hours. In 2 hours, this thing would have moved 800 miles east. And I know that because it would have gone 400 miles per hour east times 2 hours. 400 plus 400 is 800, 800 miles. All right. In addition, it would have gone, if I wanted to know the distance north in that same 2 hours, I would use this 50 miles per hour. So if I'm trying to figure out the distance north, that 50 miles per hour north is what I use. So the distance north would be equal to 50 miles per hour times 2 hours, and the distance north would be equal to 100 miles. Okay? Because when I'm working with a distance in the y, I have to use a velocity in the y. Alright? And notice that this resultant velocity does not get used when trying to calculate a distance in the x or a distance in the y. Also notice that my time can go between the different directions. So time can travel between x's and y's, alright? But the velocities cannot travel between x's and y's, nor can the distances. Alright, I hope that clears some things up. You might have to watch this a couple times. Luckily, it's only 3.5 minutes long, so it shouldn't be that hard. Alright, Wilkins out.